This is an example of a stoichiometry problem to solve involving 1-to-1 ratios to begin with. It is assumed that you know how to balance chemical equations. In this example, suppose that to 12 grams of magnesium sulfate was added to 12.0 grams of calcium hydroxide. In this example, I will show you how to find the limiting reagents, find the amount of excess reagent in grams, and find the theoretical yield of products. Note that despite the mass of both reagents are the same, the number of reacting molecules are different. In our calculations of molecules of magnesium sulfate and molecules of calcium hydroxide, we could take the molar mass in 1 mole of magnesium sulfate over 120 grams of magnesium sulfate and multiply it by the number of molecules, 6.022 times 10 to the 23 molecules per mole. This will give you 5.02 times 10 to the 23 molecules of magnesium sulfate. Similarly, while doing this for molecules of calcium hydroxide, it gives 8.14 times 10 to the 23 molecules. Notice the number of molecules are different, and therefore we use the moles. One way to successfully answer stoichiometry questions is to tabulate your data so that this helps you organize your thoughts. In your table, write down the balanced equation. Include necessary data in this particular order: the mass in grams, the molar mass, and the mole available from the mass. The reason for this is that the mass in gram divided by the molar mass gives the mole. You can fill out the table, fill out the mass of the reactants, then fill out the molar mass, the gram in 1 mole of compound. For other balanced chemical equations having different stoichiometric coefficients, it is important to make sure the molar mass is in gram per mole and not a multiple of it. This is often a common error. Fill out the other relevant information, such as the mole available in the reactants. If the mole available between the two reactants are the same, then both reactants are limiting, and there is no excess in a 1-to-1 mole relationship. In this example, they are not the same, and an additional row in our table is needed to determine the limiting and excess reagents. This extra row is called the amount required for complete reaction. Because the mole available from the mass of reagents are not the same in this 1-to-1 reaction, a fourth and last row in our tabulated data table is required, which is the mole required for complete reaction. We need to determine which of these two reagents is limiting, and my best guess is the lowest number of mole between reagents is limiting. This is not always, but often. So we need to choose magnesium sulfate as limiting reagents. By choosing magnesium sulfate as the limiting reagents, the mole required of magnesium sulfate for complete reaction is exactly the same as the mole available, because magnesium sulfate will be used up. Note the mole of calcium hydroxide required for complete reaction is 0.100 mole as well. The formal format for showing this calculation is shown here. The guess was good because only calcium hydroxide is in excess while magnesium sulfate is all used up, and therefore magnesium sulfate is the limiting reagent. The difference between mole available of calcium hydroxide and mole of calcium hydroxide required for complete reaction give the mole of calcium hydroxide in excess. And finally, to calculate the gram of excess, multiply the mole of excess of calcium hydroxide with the molar mass of calcium hydroxide to give 4.59 grams of excess. To determine the theoretical yield, this is the yield at 100% conversion. Molar product is equal to the mole limiting reagent multiplied by the ratio of the stoichiometric coefficient of the products to the reactants. For example, magnesium hydroxide is equal to 0.100 mole of magnesium sulfate, the limiting reagent, times the mole of magnesium hydroxide divided by 1 mole of magnesium sulfate. Once the mole product is determined, we can calculate the yield in grams by multiplying the mole product with its molar mass.